Okay, we're back. And now that we have a pair counts.pickle, we're going to write a script to analyze it. So we're going to say analyze.py. We're just going to import cpickle, so we'll actually just re-import it. Cpickle.load, open this file name. We want to import counter as well because it's actually a counter. So let's see what happens if we don't import counter. So we're going to do analyze. Oh, this actually, oh, I guess it actually imports counter while it loads it. Let's call it pair counts. See what actually happens. Maybe it actually imports it for us, which would be nice. Okay, it does import it for us. So this is actually a counter object. Cool. So the first one we want is, I want to try to make a matrix of all the values. So one thing we can do is we can grab out all of the potential values for any of the events. So to do that, we're going to iterate over kv in pair counts iter items. Okay, I'm just going to print k. I'm going to get back in so I can get my syntax and tabbing working. These are all the pairs. What I want to do is I want to just grab them all into a big set. So all event types equals set. So I just want to say all event types add k0, k1. So I want to just add both parts of the tuple to the set. I just want to get a set of all of them. And now if I print all event types, these are all the event types here. These are all the ones in our data set, and we can sort them. So we can, we'll just say that. Let's make it into a list to make it look nice. Now they're sorted, just so we can make it look nicer. And then what we can do is we can actually just we can actually create all possible pairs and then just print out their information. So we can say for E1 and EVTS, and then for E2 and EVTS, E1, E2. This does the cross product. It just prints all combinations, E1, E2. So these are just all the different combinations. It looks like there's a lot of them, but let's actually create all of them. Again, we're going to make this into a tuple, so then we can actually pass. Now we have all the tuples. Now we can actually pass these tuples into the counter to see how many there are. So let's go back here. Okay, so now we have tuple equals this. So now we can do lookup pair counts t to see how many there are. So now we can say print t comma pair counts t. This will actually print out each thing along with the count. So now we have a bunch of numbers, which is great. Some of these are very rare. So code lens audio, that only has 2. And then some of them might be 0. Oh, there's no zeros. Oh, surprisingly, there's no zeros. Okay, great. So now we have raw counts, which is kind of helpful, but I don't know how to interpret all this data. So what I really want is I want to get the conditional probabilities. I want to say, given that I'm starting at an audio, what are the chances I move to audio, or I move to AC error, or I move to active code? So given condition on this, give me the probability distribution of all these. And then condition on AC error, give me the distribution of all these, and so forth. So we're going to do a slice there. Okay, so how do we do that? To do that, what we can do is we can, let's construct all the possible tuples for this particular one. So let's back out a second here. So E1 is events. So we want to construct tups equals a tuple of E1, E2 for E2 in events. So what this will give us is that will give us all tuples starting with E1, and then we're going to iterate over events again to get E2. So now if I print tups, well, let's print E1 first, and then print tups, and then print. And this is what we want. So if you notice, start with audio. The things that start with audio is audio, audio, audio AC, audio active code, audio code lens, audio highlight, audio mchoice, audio page, so forth. things that start with AC error audio, AC error, active code, AC error, blah, blah. So this keeps it a little bit more organized. So now what we can do, given that we have a list of all these tuples for everything that starts with, say, AC error, we could get a total count. Let's just sum up all of their values. So how do we do that? We can iterate in tups. Recall, let's just print let's just call it T. Print T, pair counts T. Recall this. So what this will give us is, let's say, audio, for example. These are all the things that start with audio and then go to something else. And notice how we have the counts here, 2931, 27, so forth. So again, we want to add up all of these values first to get the total, and then we're just going to divide through everything by the values. So let's get the total. So total equals, we can say sum of pair counts T for T in tups. Does that work? I think so, because every time we have a T in tups, we're going to look it up, and then we're going to sum up all the values. And notice how I did not put a list comparison. If I did this, it'll actually build up a list first and then sum it, but in fact, sum works with a generator expression, so I don't actually need the bracket. So it's actually more efficient. I don't have the brackets. So let's just print E1 in total, just as a sanity check. Okay, so this is actually an interesting number. This gives us how many event pairs started with a certain thing. So notice how active code is very popular. Where 3.2 million start with this. Errors are really popular. Colin's really popular. These are all pretty popular. So highlight nobody has. Audio is not very popular, and video is not very popular. Okay, sounds good. So now let's actually divide through by these totals. So what we can do is we can now, let's add an extra print. So now we can say for E in tups, print E again, just so I don't get myself confused. So now we have the E, and then we now want to look up pair counts E. Let's just call everything T. Make it simple. These are the counts. Remember, this is the total now. This is the sum of all these. And now what we can do is we can just divide through, just so we can get the percentages. So we can actually do float divided by total. And now we actually get proportions. Great. So all these proportions should add up to 1. Should add up to 1, I think. But it's hard for us to view proportions, so let's actually make these into percentages. Just multiply all of them by 100. And now all these should add up to 100% here. So we could sanity check it, I guess. So PCTS equals 0. Let's say P equals that. TS plus equals P. Print TP. I just want to make sure it adds up to 1. And then let's print PCTS at the end. 100, I mean. Yeah, so this adds up to 100.0. This adds up to 100.0. Great. 100.0. I was afraid there was going to be some floating point problems, but they all add up to 100. If we're really paranoid, we can just assert all the percentages add up to 100.0. Does that work? There's a small floating point problem. You should never directly compare floating points. Let's just say less than 100.001 and greater than 99.9999. Let's just say that. Okay, that works. It's kind of a poor test, but close enough. We just want to get some safety guarantees. Okay, so now we actually have percentages for each one of these. To format them more nicely, let's actually format these as strings. So we actually it actually looks a little nicer. Let's format these as strings. So how do we format nicely? We can do, I always forget the syntax for this. String and then dot 2G, I think. So what happens if I do that? No, that's a dot. Let's try that. Okay, so that gives us 2 digits, 2 significant digits of accuracy, which is okay. So let's interpret these results. So for example, a page, if you're on a page event, then chances are the next event is also another page, which makes sense. 68% of it says so. 19% goes to active code, which means that you're on a page and then you run some code. And then 5% you go to multiple choice. So let's sanity check a few more. Multiple choice, you most likely are trying multiple choice again, which makes sense. And then, or you go back to the page. You rarely go to say, oh, actually you go to code, decent amount. Highlight, these things are small and so forth. Okay, so I think we got the basic idea from this data analysis. So the idea is that we actually just load the pickle out and then just munge some things and print out their proportions. So I can imagine now making a table or turning this into a data visualization as well.